either touch the pad. Everybody in the world confused. Yeah. Morning crew, and welcome back to the Andy Mechanic YouTube channel. Now, I had a sneaky hunch that I was going to be doing a second video on this, and there might even be a third. And this is to do with that Projector, basically diagnostic charger that I purchased a few weeks ago. This is the HDBM 4000. Sounds like something off Tool Time, doesn't it? Off Home Improvement. Now, there's an issue. I did a quick test with Toolgirl Jade last Saturday, which basically highlighted a suspicion, at least, sort of preliminary investigation into this component not really being suitable, in my opinion, for providing additional current into a vehicle's electrical system during a diagnostic reprogram of the ECU. Sounds very technical, doesn't it? Basically, it says in the instructions on the specifications section that this device should be able to provide up to 40 amps continuous, which is, God, my eyesight's terrible this morning, just there, look, you can see that output. There you go, which is somewhere around there. And then we've got up to 70 amps output for 30 seconds. No, sorry, 3 seconds. Engine start. There you are, look, 70 amps for 3 seconds. I think on the previous video I said 30, so my apologies, I was incorrect. So it should be able to cope with 70 amp output for a 3-second period. Now, basically what this means is whilst you're doing your diagnostics and you're communicating with the ECU and potentially doing a file upload to reprogram the ECU, which is the critical part for me, if, let's say, the cooling fans turn on or some other electrical devices, systems on the vehicle suddenly energize, obviously they're going to draw a current, especially cooling fans. They can be pretty significant on current draw, and that's going to pull the voltage down, because often you don't have the engine running when you're doing ECU reprogram. It's just key on, engine off, and that significant current draw on the loom will pull the voltage down. And when you're doing an ECU reprogram, you really do need to keep that voltage, that loom voltage, at a desired level. And whenever I do my reprogramming, normally it's 14 volts. And on the Pico scope that we used last time round on the previous video, we could see quite clearly that not only did the voltage dramatically reduce during the cranking of the actuation of the starter motor on this motorcycle. And I just want to be really clear, I'm not using any of the electrical systems on that bike. I'm not using the battery, I'm not using the bike's loom, I'm just energizing the starter motor. So there's no possibility the bike will start, there is no spark. And I said, well, you know, I reckon that starter motor is going to be about 65, 70 amps draw. Well, what we didn't do, and I did mean to do it in the previous video, was to attach the Pico scope amp clamp and actually see what the real current draw is. So, when I got back to work on Monday morning, I thought, I need to follow this up. So before the video went out, because the first video only went out yesterday, it's Saturday morning now. In fact, no, it went out this morning. Geez, about 3 hours ago. So the comments are just starting to come through. So earlier in the week, as soon as I had the data to hand, before the video was even edited, I contacted the supplier in Auckland of this device and said, hey, look, you know, I've got some results here. Could you ask your technical team to take a look, because they don't seem to match what you're saying in the unit specifications. It basically is not doing what it says on the box. And they said, oh, right, okay, no problem. And I didn't hear back for a few days. I think it was on Friday I got a message back, an email back saying, we've sent everything through to our team in Australia, and they're going to be looking at it in more detail, and they'll be in contact with you. They got back to me later that afternoon, and they said, we need you to do some more testing for us. As soon as you've got the scope and you appear to know what you're doing, I hope so, then they wanted me to gather current draw of the starter motor, especially the initial draw. When a starter motor first starts to turn an engine, the draw is much, much higher than then the continuous amount of current required to keep the engine from turning over. Keep it turning over, should I say. So I want to measure that. They've asked for that, and they've also asked again for me to do a voltage trace on the scope at the same time. So it's going to be in this video, and you guys are probably going to get this information before they do, because this video is probably going to go out tonight or tomorrow morning, and I won't be sending that email across until sometime, well, Monday or Tuesday probably. Okay, so the first capture we're going to do is the bike's all set up, the Pico scope's all set up. We're going to basically just crank the engine over. I am using a car battery as opposed to the motorcycle battery, only because it can sustain plenty of actuations without really going flat. The bike battery wouldn't be able to do that. We're going to basically do this capture without this charger in circuit. This is not plugged in on the first one, and we'll sort of get a baseline of what the car battery is able to deliver without the charger connected. Then we'll rig up the charger. I'll show you actually how to actuate the diagnostic mode on the charger, just so that the techs can watch it as well and make sure that I'm using it correctly. Clever stuff, isn't it, all this video things. Then we'll capture some files with the charger connected and set up correctly, and see just how much of a difference it makes to, it's not going to change the current flow, but it's certainly going to change, hopefully, the voltage waveform. And from then we'll be able to compare the two, and also make a call, in our opinion at least, is this unit doing what it's supposed to do? Now, rambling, but there's lots of information to get through here. Dave, I won't give his surname out, he is an agent for Sykes-Pickerton over in Australia. I didn't realise, but he's also an agent for Projector. And he just watched the first video, and he is also somewhat surprised. So he's, just waiting with bated breath to find out what the second test is gonna show. I also contacted Eric O from the South Main Auto channel earlier in the week with my results, and said, "Hey Eric, you've got a similar tool that you use when you're doing ECU reprogramming. It's not a Projector; it's a different brand. Have you ever tested yours? Because then I can compare what this is doing to how his performs." And Eric went, "Andy, you've got me thinking now." And you know what happens when Eric thinks about stuff? He usually sees it through to the bitter end and finds out what the issues are and analyses the whole thing until he's completely satisfied, which is great. It's exactly how we should be as mechanics. So he is going to test his tool. I forget the brand name. I think there's a link on his Amazon page where you can actually see that tool for sale. It's about $500 US. This one well, retail is about 1,300 New Zealand dollars, whatever that is, probably about $1,000 US. So this is a very expensive piece of kit. So you would expect it to be, provide a premium, function to doing this job. So we're going to hear back from Eric. Eric might even post a video on that. I just don't know yet. But there's a bit of collaboration going through on this one. I'm going to contact Ivan as well, of the Pine Hollow Auto Diagnostics, because I'm not sure if he's got a tool like this or not. If he has, I'll ask him to test it. And of course there's Keith. Keith may also have one of these as well, so Keith can maybe get on board and test his for us. He's a whiz with the Pico scope. Okay, enough rambling, enough links to other YouTube channels, but they do me a great favour too. Let's head over to the bike and capture a waveform or waveforms, that's current flow and voltage, without this connected, just to give us a baseline. Here we go. Okay, so first job before we can do anything is to launch that Screencast-O-Matic. And what that'll do is it will record the screen on the laptop so that I can use it in the video without any glare and stuff. Because you can see at the moment, if I move that around, we've got quite a bit of glare potential on the screen. So much better to use some screen capture software. Okay, so we'll click on record. I'm not sponsored by Screencast-O-Matic, I just find it really, really useful. Okay, so we're now recording. We can launch or go back into the Pico scope because I was doing some initial testing this morning, and it's all set up for us. We've got the current, which is the blue line here, which is channel A, and we've got the voltage channel B, and you can see at the moment the voltage is just over, what are we on? 12, let's have a little measure. There we go, look. 12.6. So essentially that battery is fully charged. Yes, I have been using it a bit, but it's still very well charged up. Okay, so I've got to clamber around the camera, and in fact we can get rid of that. Well, no, we need the camera for the audio. Okay, we'll keep that there then. Right, so we need to crank the bike. So we'll click on start, which is the play button down there, look. That should do the trick. Press stop. And then we can go back. Page 1. Ah, wonderful. That's exactly what we need to see. So we've got basically there's 0 current. And then I connect to the battery, very clean connection, which is good. And we've got a peak up here of about 200 amps. Pretty much bang on the line, isn't it? Let's have a little zoom in. We'll just close that box there for a second. It really is almost 200 amps, isn't it? Oh, Mr. Box, go away. Put you down there, look. Oh, what you move. Oh, hang on, no, sorry, my fault. Right, stick it on there. 199.7. Okay, so the initial current draw, which is obviously going to happen when you've got to try and get all the engine components to start turning, you know, initially, is 177 amps. And then that, just move across a little bit, that then quickly drops down. We can close that. And it peaks again, so the first compression stroke, at 143 amps, and then we should find it'll level out. So we'll go on to screen 2, and we can see now the regular cycle of that 4-stroke engine. So obviously it's harder for the starter modes to push the piston up on the compression stroke. So once it's settled down, we've got a draw of 66.25 amps. That's not bad. What about voltage? Let's have a little look. Well, that's pretty constant, but we'll just have a quick measure. Let's just zoom in a little bit. Use our zoom in tool. There we go. Then we can bring that down and take a measurement. So the peak voltage was 11.9, and it dropped to a minimum of, well, 11.5, and it's the minimum we're looking at. So 11.5 volts. Not very good for ECU reprogramming, but still not a bad drop. Not for a big, you know, from a car battery. Great stuff. Okay, back to the bench. Oh, it's such a nice morning. Okay, well, I think we've got some pretty good results there. Minimum volt drop. You know, voltage dropped down to 11.5 volts, and initial current draw 200 amps, and then, you know, after the first revolution of the engine, it had dropped down basically to about 65 amps, which is within the output of this device, I reckon. And you know, it doesn't take 3 seconds to get past the first cycle, so we should see some, you know, some increase in voltage, some recovery of voltage on that, on those, you know, waveforms. Okay, so the next job now is to plumb up and set on the correct, you know, function the Projector. What is it? HDBM 4000. Okay, we'll head back over to the bike. We'll get it all plumbed up. I'll show you how to set it up, and then we'll take some more waveforms. Fingers crossed, it's going to pass. I don't really want to send it back. I do need a tool to do this job. And a bit of a ball ache having to send this one back and go and find another one. Right, here we go. Right, one Projector diagnostic voltage stabiliser unit. That plugged in, it fires up, and then we need the cables. There, that'll work. Okay, now this plugs in a bit more. this plugs in just on the end there, look. Put that in there. And you get different length cables for these, which is pretty cool. I've got a 10 metre on order, but hey, I might not need them now. Right, okay. Now, it's all plugged in. We've got to connect these two connectors now onto the battery. Right, let's do the earth first. We'll put that onto there. Make sure it's a really good connection. That'll work. And then we can tuck the Pico scope pickup just under there. Now on this side, because that clamp, we're going to have to connect that as well, aren't we? Jeez, there's so much going on. Okay, well, we'll stick this one, positive, on there like that. So it's actually clamped to the clamp. And it's, again, very good connection. So I need access to the top of that pin. So we'll stick that down there like it was. And then we'll put the Pico scope pickup just in there. That'll work. And I can still get onto there, onto the post for energizing the starter motor. Easy. Okay. Right. Let's head over to the projector charger, the voltage stabilizer, and get that set up. Now, I'm going from memory here, but I believe, if I remember rightly, we press those two buttons together for 3 seconds. That gives us our diagnostic. And then we can change the parameters. We can set the voltage and set the current. Now we're already on maximum current, which is good. See the graph's all the way up. Press that again. It's charging the battery up. Press that again. We can set our voltage. 3 seconds again. There we go. And we need to go up. And we're going to set that at 14 volts. Perfect. And you can see now it's currently putting about 5 amps into that battery. Right, that's now set up. We can go back to the scope and take some fresh readings. Okay, we're all set up, so let's just press the start button and see what we get. Try and get it on the same page. Right, here we go. That should do the trick. Okay, right. Maybe I stopped just a bit too soon there. Maybe not. Maybe that's the spike there, look. Okay, so we'll go back. And we've got our initial volt drop. So this is our voltage here, look, before we basically connect the starter motor into circuit. So first of all, let's have a little look at that. We'll just zoom in on there. And bit of a messy connection, unfortunately, but nonetheless, it was still a connection. Replicates a dodgy solenoid. There we go. Right, so we've got pre-starter energization, we've got exactly 14 volts, which means that the projector voltage stabilizer is doing a fantastic job of setting the loom voltage at 14. Now, once the starter initially energizes, we've got a volt drop down to 11.73. But that will recover somewhat. So let's just close that little window and go back, and you can see now we've got basically things have sort of leveled out. The initial current draw, that's an interesting bit. Let's have a little look at that. That's one of the things that the team in Australia asked before. So we can measure that, and we'll take that up. Oh, hang on, that wasn't the plan. I wanted that one there. There we go. Oh, wrong one. My fault. Oh, there he is, right, bring that down. I would say, well, if we go for maximum, okay, 225 amps initial peak current draw, and then if we just zoom out a little bit, close that, we can see that then drops down to this peak here, so we can zoom in on that one to get a nice accurate reading. There we go, and again bring that down. I think that's a bit of noise, but if we go to there, look, we've got on the second one, we've got 164 amps draw. You can see that there, look. So we'll zoom back out. And now, basically, these peaks are sort of leveled out, so we can take a further reading on there. And that one is 66.02 amps. So once we've got the engine cranking over initially, we've got all the components starting to move freely in the engine, then the starter motor draw is 66 amps. Let's have a little look on screen 2. Yeah, pretty much the same. It may slightly increase, but you can see it is just a fraction above, so maybe it clips 70 amps. I'm really annoyed that I can't move that. Oh, there we go. Look, we use that one. What are we on? 72.89 amps, absolute peak during cranking. Okay, cool, that works. Now, the last bit, the bit that I'm interested in, is when we stop cranking, obviously current flow drops, which is this point here, and you can see that the voltage starts to climb. So the voltage during cranking, that's an interesting one. That's really the critical part, isn't it? Oh, there we are, it's my fault. User error. Okay, so we can bring that down. I think it's pretty much fair to say that our voltage there, if we were to go down the minimum voltage, we want the biggest volt drop, don't we? So I would say around about there. It's 12.82. So that's 1.2 volts less than the desired voltage that we set of 14 volts. Not happy. Okay, now obviously we did have a current draw of peak about 72 amps, which is, you know, we're way outside the 3-second initial, but as regards the initial, we've got 3 seconds, so we can do a time-based measurement. So there's our initial start of draw, and then if we bring this across and try and get up to 3 seconds, well, it takes us way off the page, doesn't it? So that's 1.5 seconds is the end of that page. So you would expect 1.6 seconds. So you'd expect during this time period for the charger to recognize this current draw and start to kick out that 70 amps and bring that voltage essentially back up to 14 volts. And you can see that even after 1.6 seconds, it hasn't done that. It's still sat at 13.3 if we're going to be giving it the best. Well, the minimum voltage actually is, what do we say, 12 point. So minimum voltage on there, 12.8. Yeah, that's right, 1.2 volts difference. So 12.8 was our minimum. So during the first 1.6 seconds, that charger, that voltage stabilizer from Projector, has not pulled that back up to the 14 volts. Okay, page 2. So 1.6 seconds in, let's just take that back to there, to the start. So if we carry on down here to another 1.4, oh hang on, we've got one at the end there, look. So what we'll do is we'll leave that one there, we'll pull this back. There we go. So we need another 1.4 seconds. And that will give us our 3 seconds as stated in the specifications. There we are, near as damn it. Okay, so again, this is the sort of second half, 1.4 seconds remaining. And again, the voltage, it really hasn't changed. We're not seeing any kind of a recovery on that voltage back up to 14 volts again. Until, obviously, we break circuit on the starter motor, which is this point here. You can see the current flow suddenly plummets to 0. And then we get a spike. Now, unfortunately, that spike is spread over 2 pages, but it's not the end of the world. So if we go next page, there we go, look. We've got this spike. Now, I'm interested to see what voltage that spike is at. It seems pretty level, actually. If we go back again. So it climbs up, continues to spike. So the peak voltage, basically, it's bang in line with that. So we've got a 16 volt peak voltage. And then, if we want to measure the time base, go back and we'll stick that one on there, and then we'll get another one. We'll have to do 2 separate measurements and add them together because we're on 2 different pages. We've got there 147 milliseconds on this screen, so 0.14. Go on to screen 2 and we can measure the time base on here. Time period. There we go. Go back. And it's finally stabilised the voltage. Or has it? Yes, to 14 volts. So it's leveled out about here. 1.35. So basically 1.5 seconds, which is what we saw on the first video as well. Okay, well, I think that's pretty damn conclusive, isn't it? Right, back to the bench. Damn, the coffee's cold. Okay, so I've just gone through the scope again. My apologies that the screen capture software was also causing me problems, getting hold of the little measuring lines and stuff. I've done it without the screen capture software now, and I've got some pretty accurate readings. So here are my results. So I'll start at the bottom so you can go through that yourself. Okay, so let's start at the top. The voltage at initial crank, so when we first energize the starter motor, without the charger connected, so the standard circuit, we got 11.52 volt drop. With the projector voltage stabilizer charger, like it says battery charger on the box, that was a slightly less of a drop. It went down to 11.68, and you can see that on there, look, 11.68 versus 11.52. Marginal difference, but there is a difference. So obviously the charger's doing something. During cranking, for the period of time that we cranked, with the baseline was 12.55, but with the charger connected we got 12.91. So that was a reasonable increase. However, not the 14 volts that I was expecting to see. Peak current. Now this is something which the team over in Australia has asked for specifically, and I'll be sending them the Picoscope files so they can, and I think I'll put the Picoscope files links to them in the description on this video so you can take a look as well, as I'm sure Erico and Ivan will be very interested. So the peak current, so as soon as we connect the starter motor, the large amount of current required to get that engine to initially start to crank over. Without the charger connected, it shouldn't really make much difference, but we had 222.5 amps without the charger connected and 221.1 with it. I don't think there's an insignificant amount of difference in that. Shouldn't really make a difference at all. During cranking, so that the sustained ding, 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 okay, soundbite for you, as the engine's cranking over regularly, without the charger connected, we got 61.68 amps, and with the charger connected, 61.68 with the charger not connected, the standard circuit, and 68.58 with the charger connected. Again, it shouldn't really make much difference. What was important to me was, as soon as we finished cranking, how long does it take the charger to re-establish a battery voltage? Well, obviously when there's no charger connected it's irrelevant, so we've got a little dash on there. With the charger connected, to get that voltage after the peak back down to 14 volts, a nice steady 14 volts, which is the desired voltage that we set on the charger at the start, it took 1.58 seconds, almost 1.6 seconds, to bring that voltage from the peak back down to 14 volts. Now the one thing that I've not included on here, which I'm going to measure now, is the peak voltage post crank. How high does it spike? Now that's pretty important, and I think the larger the battery, the lower the peak's going to be. So maybe on a motorcycle battery, a little tiny battery, that peak could be substantially more, which is a little bit worrying when it comes to ECU reprogramming, because they don't like that kind of stuff. Right, I'm just going to pop over to the Picoscope now, take one more measurement of peak voltage. I've got it on the screen, and I'll come back and tell you what it is. Bear with me. Go and have a quick coffee. Not a cold one though. Okay, I'm back from my final analysis. So after cranking, as soon as I disconnected the circuit, starter motor is de-energized, we got a peak voltage of 16.08 volts. That's quite high, isn't it? But it was only for maybe a second. and it did sort of climb up to that. That was the peak. So, a bit of a concern. It's quite high. Is that going to cause the ECU or other components in the vehicle an issue? I don't think so, but it might. It certainly could disrupt the communication between the laptop and the ECU, and if you're uploading a file at that time, it's not good, is it? So I'm going to send all this information through to Projector, both here in New Zealand and the technical team in Australia, and Dave and Eric O, and probably Ivan as well if he asks for it, and see what they think, and so they can compare this data to testing similar devices that they use to do the same job when doing ECU reprogramming and so on, and see how this tool compares to the others that are on the market. Basically, if it's comparable, then probably it's okay. If there's a big difference in how their tools control and stabilize the battery voltage, if they react quicker, and also we don't get that big long lag after the current draw has ceased before the desired voltage is attained, and maybe their tools don't give such a high peak voltage post crank or post heavy current draw. You know, interesting stuff to compare. Well, there you go. That's about all I can do today. I've got an ROV outside. I've got a ton of servicing work to do on, and it's got to be ready by next Sunday. So I've got to crack on with that. Hopefully, you found this video interesting. I imagine that most of you, when you won't be buying a tool like this, but if you are involved in ECU reprogramming or anything that involves communication with ECU on a vehicle, then you know, this is the kind of, I'm not saying that this tool is what you want, but certainly you're probably using a similar kind of tool, or you should be. And you may well have found what I've highlighted in this video of interest, and maybe it's got you thinking about the tool that you've got. And if you've got a Pico scope or any kind of oscilloscope, you can take the same readings and get an idea. A Sunday morning thing, I think. Alright chaps, well, if you enjoyed the video, why not click on the subscribe button. You'll see a little gear icon turn up. Click on the gear icon and you can tick the box and turn on notifications. You'll also find me on Facebook, Instagram, Google+, and Twitter. Feel free to communicate through any of those portals. However, first point of contact, if you don't mind, via the comments on YouTube, because let's face it, that's where I am most of the time. There's also a new or recent Patreon page. You can drop onto that and find out a bit more background information about the channel, how it came about to be, and up and coming projects. And I've got a huge project coming up. Yeah, well, no spoiler alerts at the moment, but there's a huge project about to start in the next couple of months, which is going to take up a lot of my time. No, it's not a sponsorship deal or anything like that. I'm just changing things a little bit. Okay, well, oh yeah, on that portal, if you would like to make a donation, you can do. There's also some swag that you can purchase, and that's available through Uniform NZ, and there's a link in the description on this video too, so you can get your own shirt. Or if you've got your own personal tool girl for your workshop, then you can get her one of the Andy Mechanic shirts. They're very smart. All right, chaps. Well, that's about it. Until next time, enjoy your coffee. I'll see you around. Cheers. Over and out. And we get the flip again.
Oh!
Yes!